Not just the answers, but an in-depth explanation of all the solutions. Don't be scared of this paper. Join me now and I'll show you everything. Let's go. Question 1, and it's cold, and it's getting even colder. It says a temperature that is 8 degrees colder than -5. So you can imagine that there's 0 degrees Celsius. Then it gets really cold, so that will be -5. And then we need to go down another 8 degrees. That gets really cold. So basically what we're saying is it is -5, and you take away another 5, it's -13. Very cold. Yeah. But that's the correct answer. Question 2. Prime numbers. You need to remember what is prime numbers. Prime number, of course, is a number with only 2 factors, and exactly 2. Meaning the first prime number is 2, not 1, 2, because 2 can only be divided by 2 and 1. The next prime number will be 3, because 3 can only be divided by 3 and 1, without a remainder, of course, decimals. 4 is not a prime number because you can divide it by 3 things, 1, 2, and 4. So the next prime number will be 5, then it'll be 7, then it'll be 11, and so it goes on. Alright, so when we look at these numbers up here, we need to kind of know our times tables, okay? Let's do some elimination here. Anything ending in 5, of course, can be divided by 5. So the only prime number with a 5 in it is 5. Is that true? Let me know in the comments. Okay, 93 is pretty basic. Yeah, 93, because you can divide 9 by 3 or 90 by 3. That will be 30. You got 3 by 3. That will be 1. So 93 can divide by 3, you get 31. That's no prime number. In fact, anything that you add the digits together and the sum can be divided by 3 is in the 3 times table. For example, 57. If we take 57 and we add the 5 and the 7, we get 12. Now 12 is divisible by 3, that's 4. That means 57 is divisible by 3. Which, by the way, would be what? 19? No? Yeah? 57 divided by 3. 19. So that has got... Alright, so we've whittled this down to 3 numbers. Now the magic is here, you've got your calculator. Okay. Oh, well, there's another one that's really easy. 27. You know 27. 27 is a 3 times table, but in case you were unsure, 2 plus 7 is 9. 9 is divided by 3. In fact, 27 by 3 is so. 47 and 61 must be our 2 prime numbers. Okay, I guess they want to check then if you know what sum means. Sum means adding up. So 47 plus 61, 108. Which is correct. 1 mark for identifying 47 and 61, in case you don't know what sum is. Right, Stefan seems to be waiting for the train every single day, or 10 days at least. And sometimes you wait quite a while. Complete the stem and leaf diagram. Okay, so remember, in the stem and leaf diagram, this is the tenths, sometimes tenths, and this is the units. Okay, so meaning they've already put the first 2 numbers in the stem and leaf. The 1 is there, 3 is there, then the 12 will be a 1 and a 2. Okay, but use a pencil for this. Show you now why. Okay, then there's the 5, then there's the 4, then we got 23, we got another 5, then we got another 24, then we got 11, so 1, and we got 8. Now the thing with a correct stem and leaf diagram is it's always in the right order from smallest to biggest, which ours is not. That's why I said use a pencil. But let's change that. 2, then we got 3 and the 4. That is the right order, so I'm going to put that in pen. Okay. But here, the 2 and the 1 is not in the right order. It should be from the smallest to the biggest. And the last one there as well, we need to swap this 4 and the 5. Okay. And let's put that in pen. Okay. Stem and leaf diagram, correct. The numbers needs to be in the right order as well. Let's see. So yes, you only get 1 mark for a fully correct, unordered. So if they're not in the right order, you're going to lose a mark. Remember that. Next, find the median. The median is now the middle number. So one way is we can take these numbers up here and write them from the smallest to the biggest. We kind of already did this here with 1 being the smallest and 24 being the biggest. Now there's 2 ways to find the middle. One way is to just chop it in half. Now be careful, right? We're going to chop it in half. We need to do 10 because there's 10 numbers plus 1 divided by 2 gives us 5.5, which means the middle is between the 5th and the 6th number. So let's count that. I'm going to use the pencil again. So we got 1, 2, 3, 4, 5. That is the middle right there. So now we got 5 numbers that's smaller and 1, 2, 3, 4, 5 that's bigger. So the middle is between 5 and 8. Okay. So somewhere, what's between 5 and 8? What's in the middle? Is it 6? Is it 7? 6.5? If you're not sure, you can add them together and divide it by 2. 5 plus 8 being 13. 13 divided by 2 is 6.5. So 6.5 minutes. Okay. Another way of doing this is just by chopping it up from the sides. Yeah, the smallest number is 1, the biggest is 24. Second smallest, second biggest. Third smallest, third biggest. Fourth smallest, fourth biggest. And then we got these 2 numbers left, so it's in the middle there. Same thing. Okay. Either way, 6.5 is correct. Question 4. Right, map scales. There is 1 to 250,000. Okay, one of the questions I get all the time from students is, but there is no units. 1 watt, 250,000 watt. And it says that the units doesn't really matter. It says anything that's 1 on the map is 250,000 in real life. Meaning 1 millimeter on the map will be 250,000 millimeters in real life. 1 centimeter on the map will be 250,000 centimeters in real life, etc. Okay, so we just need to make sure we got this ratio correct. Let's write it down. So on the map, we have a distance of 1, and then reality, real life, whatever, the real distance is 250,000. Now the measurement they gave us was on the map, so that is 3.5. And now we can put in some units, centimeters. Okay. How do we get from 1 to 3.5? Well, we just simply did the ratio 3.5 times. So we do the same here, 3.5 times. Okay, so we take the calculator. And there we go. 875,000 centimeters is the distance in real life. And of course, because we don't talk that I'm gonna travel 875,000 centimeters, we need to change it to kilometers. Okay, so remember this. To go from kilometers to meters, what does kilo mean? Of course, 1,000 times it by 1,000. 1 kilometer is 1,000 meters. To go from meters to centimeters, how many cents in a dollar? 100, of course. Alright, so, but we're going the opposite, aren't we? We're going from centimeters to kilometers. So let's just do it in the opposite direction. We divide by 100, and they're the same. We go in the opposite direction. We divide by 1,000. Okay. Meaning we take the 875,000 and divided by 100,000. That will give us kilometers. So we divide it by 100 to change into meters, 1,000 kilometers, bam. 8.75 kilometers. Sounds to me like a well reasonable answer. Of course, it's correct. There we go. Okay, there's another way you can change it before the ratio, before you do the multiplication. Whichever way you fancy. Note here, many candidates struggle changing those kilometers, centimeters to kilometers. So practice that a little bit. Spinner is spun. We got probability. Complete the table. So the spinner only has 4 options, A, B, C, and D. Alright, they're obviously different sizes. D being big, so 35% of it landing on D. C being small, only 5%. What they want to test is if you know that all probabilities adds up to 1, if it's in decimals and fractions. If it's a percentage, it adds up to 100%. So all we really need to do here is we need to subtract all these probabilities from 1, and then we'll get the probability of the spinner landing on B. Which gives us 0.4, and that's it. All you need to do. 0.4 or equivalent, meaning 2/5 is fine, 4/10, 40%. Okay, 1 mark for the working out, so show it, show your working out. That is important. Interesting here, if you did put it in percentages, put the percentage sign or you lose a mark. Okay. Also, very important to notice here, if the candidates, they call them, that's you, didn't show the working out, they lost the method mark. Okay? So, if you don't show this, this is important. This, ladies and gentlemen, is important. This counts a mark. Show it. Show it. 1 mark. 2 marks. Don't show it, don't get the mark. Okay, working out is always important. Question 6, we got sets. We got a universal set. So we're looking at all the numbers between 1, from 1 to 20, including 1 and 20. Because it's a less than or equal sign. Right, now, then we got one set where E is all the even numbers and M is the multiples of 5. Now you don't have to do this. Okay, but if you want to draw a little Venn diagram showing this, you're perfectly allowed to. So what this represents is inside this box is all the numbers 1 to 20. Then we have 2 sets. This one will be all the even numbers and this one will be the multiples of 5. Meaning 1 is not even, it's not a multiple of 5. 2 is even. 3 is not even, it's not a multiple of 5. 4 is even. 5 is a multiple of 5. 6 is even. 7 is neither. 8 is even. No, wrong place. 8 is even. 9 is none of those. 10 is even and a multiple of 5. 11 is none of those. 12 is even. 13 is none of those. 14 is even. 15 is a multiple of 5. 16 is even. 17 is none of those. 18 is even. 19 is none of those. And 20 is even. That's it. That's what it means. I want you to visualize that in your head. So, answering the questions. N means number. The number of numbers that is multiples of 5, and that's 4. 5, 10, 15, and 20. So that's 4 numbers. The answer here is 4. Correct answer only. There's nothing else you can write there except 4. Okay, most common mistakes is people list the numbers. Okay? So they write numbers 5, 10, 15, 20. Instead of 4, there are 4 numbers. Okay? If you put it in those curly brackets, which indicates a set, you lost the mark. Don't put in curly brackets. Okay. This was the worst answered question in this question. Wow, interesting. Find the elements in the set N intersect with M. Okay, remember these things, alright? Intersection means something that is in both. The one and the other. Where the other one, the union, is or. The one or the other or both. Okay, so this means the elements. So we're going to list a set now. That is an even number and a multiple of 5. And those were just 10 and 20. It's the only two numbers. Okay, and they're not asking n. They didn't put that n. Answer 2. So 10 and 20. Okay, those curly brackets doesn't seem to be necessary though. Oh, so actually I should have put the brackets, but they didn't mark it wrong. Okay, don't put the brackets. But it's not wrong if you do. They didn't mind if you did. Question C. Got a new symbol here. Element. Okay, this is the element sign. Element simply means, right, parts. For example, if we can say that 2 and 14 is an element of E. You know, you can have 2, 14 is an element of the set E. It's in there. Okay. Now, of course, if there is a line going through it, this means it's not an element. It's not in there. Okay, so Y is not an element of E. So that'll be what they ask. We can any of these numbers that is not in E, we can write down 1, 3, 7, 9, 11, 13, 17, 19, 5, or 15. Any one of those. Pick one. Yeah, let's take 11. 11 is a good one. I like it. 11 is not an element of E. Okay. An odd number or decimal, we can write a decimal in the range 1 to 20. So any one. Any of the odd numbers. Yeah, basically any of the odd numbers. Even decimals. Okay. Okay. Some students wrote all the numbers, which is unnecessary. It just means write on a possible. So they say read the question carefully and do what they say. But if you wrote all the odd numbers, they gave you the mark. Question 7. Without a calculator, we need to calculate this. 4 over 7 divided by 1, 5 over 21. Answer, 6/13. Right, I got the right answer, of course. Easy stuff. 0 marks because we said without a calculator. So I need to show all the steps in between, and then it'll give me the mark at the end. Alright, so to get full marks, we need to show the following. First thing, we're going to change this mixed fraction to an improper fraction. You do 1 times 21 is 21, plus 5 is 26. So that's 26 21s. Alright, this is division, so we don't need to get the denominators the same. It's a common mistake students make. Only when you add and subtract would you multiply the 7 and the 4 by 3. Okay, this is unnecessary. With division, what we do is invert and multiply, which means we swap this fraction around, which I haven't done. 21 at the top, 26 at the bottom, and we multiply. Okay. Now, doing 7 times 26 without a calculator. It's not impossible, but there is easier ways to handle the situation. We can simplify now before we multiply. We can divide this 7 and that 21 by 7. 7 divided by 7 being 1, 21 divided by 7 being 3. We can divide 4 and 26 by 2. So 4 divided by 2 is 2, 26 divided by 4 is 13. Okay. So now, 2 times 3 is 6, 1 times 13 is 13, and we got the right answer. Let's see how they award marks here. Okay. So, looking over here, yep, 1 mark for the improper fraction, then they'll give it another mark for inverting and multiplying, and then they give you the mark for the correct answer. Question 8a, solving. Alright, whenever we got a fraction, when solving or with algebra basically, get rid of that fraction. And that's what we do by multiplying both sides of the equation by x, or multiplying the x on the other side because it's being divided. So 6 times x, x times 6, 6x. Then we can divide the 6 over there. What we're basically doing is we're swapping the x and the 6 around. Okay, and then 30 divided by 6, what is that? It's 5, isn't it? Which is correct. Next one is an inequality. It's quite important with inequalities to keep things organized, and yeah, you got a left side and a right side. Leave it that way. Don't confuse things. Keep that sign in the middle. Right, expand the brackets is the first thing you do. 2 times 2x is 4x. 2 times 9 is 18. Okay, now we can rearrange things. Okay, whichever method you prefer. Do the same on both sides, or you move stuff across. Either way, I would get rid of the 4x on the right hand side. You can subtract the 11x because then we got a negative, which is bad. 11x minus 4x is 7x. And we got the 18 on the right hand side. Okay, next thing is get rid of that minus 3. So you add 3 on the right. So we got 7x. And 18 plus 3 is 21. And the last step would be to divide by 7. So x. And that's the correct answer. Make sure to write the correct sign. Final answer, 3 marks. Well, there it is. I guess you get a mark for every correct move you make, and then the answer. Right, question 9, vectors. And I think it's very important that we understand what is going on here. First, with a column vector, we have 2 numbers. The number at the top tells us how many spaces or units or whatever we're moving to the left or to the right, horizontally. Of course, going to the right if it's a positive number. If it's a negative number, we're going to the left. And the number at the bottom tells us how many units we're moving up or down. Of course, if it's positive, we go up, and if it's negative, we go down. Okay. So what they've done here, they gave us a starting point, 1 minus 4. So let's, I want to visualize that over here. Okay, so 1 minus 4, we go along the corridor to 1, down the stairs to minus 4. This is not working. Okay, down the stairs to my goodness, I need some practice, don't I? Minus 4. So this will be the point F. Okay. Next, they give us a vector. Okay, FG. So FG is the number 8 minus 3. So it means we go 8 spaces to the right, because the top number is 8 and it's positive, and we go 3 spaces down because it's negative and it's the bottom number. Alright, where do we go? So from F, 8 spaces, 1, 2, 3, 4, 5, 6, 7, 8, and 3 down, 1, 2, 3. Now this will give us our next point, which is G. Okay, so that was 8 minus 3. And that is what a vector is. It's something that moves in a direction. Okay, like this. That is the vector FG. And put an arrow in there because it's got direction. Right. That's what it means. So what are they asking? Now they say 3FG. So what we need to do here is we need to take this line, FG, and make it 3 times longer. Okay, this is not difficult to do because it just means instead of moving 8 spaces to the right, we now need to do that 3 more times, which will give us 24 spaces to the right. And instead of moving 3 spaces down. We'll do that 3 more times, which is 9 spaces down. See, that was pretty easy to do. Okay, and that's the correct answer, and it says lots of candidates got this right. The next one tells us FDGH. So here they got another one, GH. This tells us now we need to move 12 spaces to the left and 35 spaces up. I think I'm going to be able to do that over here. I don't think so. So 12 spaces to the left. It's not working. There we go. 1, 2, 3, 4, 5, 6, 7, 8, 9, 12 and 35 spaces up. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17. Yeah, I'm out of space. Okay, but you get the idea. It simply means we're gonna end up somewhere insanely up there. Okay, but there's an easier way to do this without having to draw all of it. We take the vector of FG, which is 8 minus 3. We add to it the vector of minus 12 over 35. And yes, easy as that. 8 plus minus 12. We just add the two horizontal vectors. 8 plus minus 12. 8 minus 12 gives minus 4. Okay. And we add the other two vectors. 35 minus 3 being 32. Let's check. And that's correct. Okay. Part C is finding the coordinates of G. So here we got FG. Alright, and I've already kind of done this. FG, when I drew this one, you see there's FG. What's the coordinates? If we look up, yeah, that is 9, so that's 9, and we go to the left, that's minus 7. Along the corridor, up the stairs. 9 minus 7 is my opinion. Okay, is that correct? Yes. How to do this if you don't have a grid to play around with like I just did, okay? Just remember that the one that is the x value, and the x value is the x-axis. And the minus 4 is the y value, that's the vertical axis. And in our vector, horizontal is represented by the top number and vertical by the bottom number. So if I've got a 8, this was like this, it was 8 minus 3, wasn't it? So, and the point we started off was 1 and minus 4. So to the x value we need to add the 8, which is the 9, and to the y value we need to add the vertical, which is minus 7. And that's how we do that. Alright. Question G does ask us to find the magnitude. Means how big is vector GH? What is GH? GH is minus 12, 35. Okay. So let's visualize for ourselves what they're asking here. Did some preparation. Here we go. So this would be the vector GH in purple going in that direction. You see that? Yeah. From G to H. Going 12 units to the left. Was minus 12, but in the end it's just 12 units. We could put a minus there if we want. And then going 35 units up. Okay. You can see that forms a 90-degree angle and a beautiful right angle triangle. Okay, and the magnitude means simply how long is this purple line, which is the vector GH. That's what they're asking. And you can see it leans beautifully towards what we call Pythagoras when we're working with right angled triangles. And we got two sides and we want to know the last one. Okay. Remember how we did Pythagoras? Let's label this A, B, and C. That means A squared equals B squared plus C squared. Or simply A equals the square root of B squared plus C squared. Okay. So when we're working out the magnitude of this one, okay, the actual coordinates, which I plotted there accurately, doesn't matter, because in the end, it doesn't matter where you are on a grid, you're moving 12 spaces and 35 spaces. So it won't change the magnitude of the grid if you shift it to a different place. So the actual coordinates is not important. All you need to know is if you want to find the magnitude of GH, which we indicated like this because it's always a positive number, we need to do the square root of the two values squared added together. Of course, it's Pythagoras. Okay, now there's a minus 12. Put it in brackets. Or you can just use 12, because in the end it's just 12 units to the side. It doesn't matter which way you go. It's going to be 12 units. So you can do just 12 squared, but if you're going to put the minus, put it in brackets, because you need to square that negative, and 35 squared. That's all we need to do. Okay, so let's do that in brackets, negative 12, or just 12 squared. 12 squared and minus 12 squared gives us 144. It's the same thing. And we get 37. That simply means that this length of the purple line is 37 units. So, now we know. Is it correct? Yes, it is. There's the working out. You see those brackets? They show it there. Put it. It's important. In the examiner's report, they said the same thing. Candidates need to be aware of the difference between minus 12 squared without the brackets and with the brackets. Put the brackets. Question 10. Transformations. Remember the 4 types of transformations. What are those? Yeah, there's the reflection. They've got a mirror line. We have one we often spell wrong, translations, not transformations, is all for translations, not transportations, something like translations. You've got a vector, right, going left, right, up, down, moving across the page. We have rotations, spinning around, we got enlargements. Right, so in question A, they'd say, so describe fully the single transformation. It means you need to tell firstly which one of these 4 is happening. So let's have a look. We're going from A to B. We're going from A to B. So let's trace A. You can just do this by hand. Okay. So let's see. Is it an enlargement? No. It is not getting any bigger or smaller. Is it a rotation? No, it seems unlikely if it's a rotation because 180, no, not quite there. Okay. Is it a translation? Translation means you move across the page. No, it didn't just move up. So obviously it's a reflection. Reflection means it's got a mirror image, or rather, if we flip it over, yeah, see, that fits exactly. Flipping over. Okay. So once we determine this is a reflection, we write it down, because that will give us our first mark. Oh, you see, I wrote it down. That will give us the first mark. Right. Note that this question counts 2 marks. So we got 1. So we need to write one more thing. This also helps us to determine which one it is, because enlargements usually those counts 3 marks. For what's the 3 things? Writing enlargement, writing the center of enlargement and writing the scale factor. Rotations usually is 3 marks. That would be writing, it's a rotation, writing the direction, clockwise, anti-clockwise, and the angle, 90, 180, 270, and the center, 3 marks. Translations usually is 2 marks, because you need to write as a translation, and the vector, reflections usually counts 2 marks as well. So what do we need here for the reflection? We need the mirror line. That is the line it reflects in. That's the line that all the points are the same distance from this line. It's the line it flips over. You see, the distance there is the same as there. The distance from there, 5 squares, is the same as there, right? So in here we write mirror line will be the line that goes through the y-axis at 2. And that will give you y equals 2, gives you your second mark. Question B now tells us rotate the shape A 90 degrees clockwise about the point -2, 2. So along the corridor, up the stairs. Along the corridor, up the stairs. That is the point we need to rotate it around. So let's take our shape. Put the pencil at the center. We need to rotate it around. We're going clockwise. Look at the wall. Clockwise is this way around, 90 degrees. 90 degrees would be like this. Okay? 180 is half a turn. I don't know if you can see that. My fingers are on the way. 270 will be 3/4 of a turn. Something like that. Something. Okay, but we're going 90 degrees. Okay, so look carefully. Let's mark the corners. Alright, and then we take a ruler and a pencil. Because if you're not accurate enough, they're not happy to give you your marks. Make sure the shape doesn't change in any way or form. And there we go. Alright. You can also, it's a 90 degree turn. If we connect that acute angle with this new shape, see, we've got a 90 degree angle there. We know it's correct. Alright, last one. Enlarge shape A by a scale factor of a -2. And the minus doesn't mean it gets smaller. A fraction means it gets smaller. Center 2, 0. Let's start with the center. 2, 0. Along the corridor, up the stairs, which you don't. So that's the center. Okay. If the scale factor was 2, it means we had to make this shape twice as big on the other side, which will be off the page there. Okay, -2 means simply we need to enlarge it twice as big, oh my goodness, on this side. Okay. Oh, look, I'm looking at B. A, sorry. Enlarging shape A, be careful, twice as big means, right, it will be over here, twice as big over here. But that is just 2. -2 means twice as big on the left hand side. Alright, so what we need to do is we need to draw some guidelines very accurately going through the center on the other side of the shape. Like so. Edge corner going through there. Alright, these are just to help us. Now we look at the distance. You see this distance from here to the center is 1 square, going 1 down, 1 across. -2 means we need to go to the center and then double that distance. So we go 2 down, 2 across. That is where that acute angle will be next. This point here is 1 to the left, 1 going up. So the new one, minus 2, means from the center on the opposite side, we go 2 across, 2 up, which is good. Now that distance there, which was 2 squares before, now is 4, double as much. Alright, we keep doing that. This point here is 2 squares to the left, 3 up. We do now 4 squares to the left and 6 squares up. Okay, just be careful, right? Because it's clearly my line that I drew here was not very accurate. Last one, 1, 2, 3, 4 squares to the left, 3 up, becomes 8 squares, 1, 2, 3, 4, 5, 6, 7, 8. And instead of going 3, we now go 6. That line was drawn quite accurately. So on the guideline, and then we connect the sides. Okay, this is a bit of a mess, I have to admit. Just make sure they can clearly see where the corners of your shapes are. No need to rub anything out, just make sure it's nice and dark. Okay. And there we go. Question 11. Read the information carefully. It says that there's 2 sectors of circles with the same center O, so that's the middle of the circle. They tell you these things because it's important. Both sectors' angles are 140 degrees. OC is 3.2, we can see there, CB is 2.6. I simply say it because we're going to have to use it. Okay, I think a good thing to do here is to separate the 2 sectors. That will help a lot. So there's the bigger sector. Oh my goodness, that's an ugly sector. Alright, there's the bigger one. And there's the smaller one. Oh, this is even worse. Okay. Now the bigger one has got A there. It's got B there. It's got O there. It's got an angle of 140 degrees. The smaller one goes from C to D. I got O in the middle. It's got an angle of 140 degrees. Smaller one's got a radius of 3.2, of course, and the bigger one has got a radius of those 2 added together. You see, these arrows clearly show you what is meant. That, of course, will be 5.8. Okay. Now they got this funny thing with a pi and a k. Man. If that throws you off, just forget about it and do what you know. They're talking about the area of sectors. What's the area of a sector? That's straightforward. Remember, you do the area of a circle, pi r squared. Now a sector is just a fraction of that, a fraction of the angle out of 360 times that. Okay, and that's the area of a sector. It's not a difficult formula to remember. Okay, this funny shape, funny egg I put, that's theta. That's just the angle at the center. Okay, represented by that sign. The angle at the center divided by 360 give us the fraction of the whole circle we have, which we work out by doing pi r squared. So let's do that. Let's do the big sector. Okay. They both have an angle at the center of 140 by the radius of the big one from O to B, 5.8 squared. Okay, let's put that in our calculator. All right, now my calculator's done a beautiful thing. I mean, there's the answer, 41.099, etc. We can write that down, but the more accurate answer is this one. Okay. Because it is in pi form. If you don't have a calculator like mine, you can work this out by doing the whole calculation just without the pi. Okay. So let's do that. Let's do the whole calculation just without pi. So there it is. Okay. And it gives us that. So I'm going to write down this. The final answer, because this is the most accurate, 5,807 over 450 pi. It also hints towards what they want here, a number and a pi. Okay, let's do the small sector next. Okay, so that will be the same. The angle is the same. Formula is the same. Only the radius now is from O to C, 3.2 squared. Let's put that in. Okay, we can just change this. 3.2. If you want to do it with pi, you can do that. Alright, see, 896. I mean, you can write this down if you want, but this is better. 896 over 225 pi. Okay, now of course we only want the shaded area. So it's like having the big sector with a smaller sector chomped out, cut away. So we subtract. And you can do this calculation with or without the pi there. Okay. So what did we have? We had I'm just going to subtract my previous answer, which was that one, and there we go, 91 over 10. If you got this one, that's the correct answer, but they want it kind of in pi form. So the answer will be 91 over 10 pi. So what is k? K is the thing in front of the pi. 91 over 10, which is simply 9.1. If you want to write it as decimal. I assume both will be correct. Which question was this? 11. 9.1. They don't say or equivalent, which is weird. Usually they just put the O and the E. That means 91 over 10 would be correct. Let's check. No. It's funny. Let's see if the examiner's report says anything. Nothing specifically over the 91 over 10 I can find in the examiner's report. I assume they will both be correct. Let's move on to question 12. Right, question 12 is something a bit new, a bit confusing. They say find the value of b. I mean, we can overthink this, but let's just do what we can. I mean, we got write down the equation. They tell us x could be 8, so let's put an 8 where the x is. That will give us, 8 squared, 64. So that means we've got 64a plus b equals 181. What's next? Well, it tells a and b are both positive integers. Integers, remember, means whole numbers greater than 1. So that means it could be 2, could be 3, could be 4, could be 5, couldn't be 1. So if, for example, oh goodness, there goes my pen. If, for example, a equals 2, alright, if a equals 2, so 64, a is 2 plus b equals 181. 64 times 2 being 128. Then b must be 181 minus 128. What is that? 53. Then b must be 53. Okay. What if a was 3? That's just for a investigation. If 64, if a was 3, what's 3 times 64? Well, that's 192, right? Isn't it? Yeah. So that means b must be minus 11. But it tells us a and b are both positive integrated ones, so a can't be 2. A can't be 1 because it's greater than 1. So the only thing a really can be is 2, to be honest. So I think we figured this one out. Alright. How did I figure it out? I just started by writing down what I know. I wrote down the equation they gave us, I put in the equation what else they gave us, and then I read the other information they gave us to try and figure out what could be the possible answers. It's kind of one of these questions you have to reason out. Yeah, it's correct. Look at that, you get 1 mark if you just substitute that 8 into the equation. So see, it's 2 marks, you can get an easy mark just by doing the first step. Do not fear, just do what you can. See, it says many of the candidates didn't understand the importance of the second line of information they give you. So always pay attention to all the information they give you. Okay. Now, same thing goes with B here. It's a little bit confusing, but I can see here that they want to know what x equals. This is the wrong color. Alright, so let's just work out what x is, right? We've determined now in the previous question that a is 2. So I'm going to write this equation again. Instead of a, I put 2. And we got x squared, and I need to put it in brackets. So it's a is 2, x squared, b, we got there, is 53. And let me just solve this. So 2x squared equals 181 minus 53. Must be easier because I didn't give us much space to do this. So what is that? That is 128. Then we divide it by 2. So x squared is 64. Of course, of course. So x will be the square root of 64, which of course, they gave us the one answer. There it is. It's 8, square root of 648. So what could be the other one be? Well, of course, when we square root something, there is 2 answers. So it's a positive or a negative 8. So it will be negative 8. So that's, they didn't want you to work it out. Think this, you should know it's negative 8. Why is it negative 8? Because if we square a negative answer. Because 8 squared is 64. And minus 8 squared in brackets is 64. That's why the square root of 64 has got 2 answers. Easy as that. Easy as that. Just minus 8. You don't have to do all that working out. I did. Question 13. Clearly we have a circle theorem question here. And it's very important with these questions to read through all the information. They tell us A, B, C, D are points on a circle. We can see that. They tell us for a reason. AB is parallel to DC. Okay, so the moment you see parallel sides, you know you're going to look for that Z. Alternate angles. Or maybe the F. Who knows? Corresponding. Okay. So looking at that, I immediately see here. There's a Z. So meaning this angle here is 32 degrees. And the LCD is 32 degrees. Chords AC and DB intersect at E. Be careful now, they don't tell us that this is the center of the circle. If they told us this is the center of the circle, they would say it is the center, and they would put a little O there, like so. But they didn't put a little O there, so we don't know if that is the center of the circle. Okay. What other theorems can we look for? Well, there's angles in the same segment theorem. Let me show you. There it is, see? It's the butterfly or the bow tie or the bat theorem, whatever you want to call it. Can you see here that the 2 green angles are the same and the 2 orange ones are the same no matter how I move it? Yeah, you see that? 28.7, 28.7, 24.3, 24.3. Going back here, that means that angle C and B is the same, 32 degrees, 32 degrees. What does that give us? Well, interesting enough, which has got no relevance actually, it means these are isosceles triangles, which means all those lengths are the same. It means that E must be the center of the circle. Okay, it's like so. Like if I move this for these lines to cross in the middle, see that? If it crosses in the middle, those angles are all the same because the radiuses are the same. But actually this has got no relevance because we just want to know what x is, and we got two angles in the triangle, so to find the final angle, we subtract the two angles from 180. That's 180 minus 64 is 116 degrees. And there it is. Okay. Show the working out, because in the examiner's report they said that if there's a slight calculation mistake, you get your marks from working out for the method. Okay, show that. Question 14 is the function, and they want us to find the inverse of the function. That means we are rearranging the equation. Okay, and to just make things a little bit easier, to make it a simple equation, is that I change the fx for a y, because that means that when we rearrange it, we need to make x the subject, we move the 2 to the other side, then we move the 5, so it becomes y minus 2 divided by 5. Okay, when you write your final answer, make sure you swap that y back to an x. So it's x minus 2 over 5. Another way of doing this, of course, is thinking inverse. If you got x there, what's the first thing that happens to it? Well, it gets multiplied by 5. That's why you got 5x. And then you add 2 to it. That's how you get 5x plus 2. Now, the inverse means you just do it backwards. First you subtract 2, and then you divide by 5. X minus 2 over 5. That's actually more explanation of what we're doing. Alright, anyway, that's the final answer. I don't know what could be equivalent to that, but there's something equivalent. Question 15, and they give us 2 points. Point C, 5 minus 1, and point D, 13, 15. And ask us to get the midpoint. Let me show you what we have here. Right, so at the bottom there I've got point C, 5 minus 1, and at the top I've got point D, 13, 15, and that purple line shows us the line we have to find the midpoint of. Now, one way of doing this is, of course, let's have a look, alright, is taking the horizontal distance, which there goes from 5 to 13. Now, what is 5 to 13? That is 8 squares. Halfway, of course, that with 8 is 4, so 5 plus 4 is 9. The middle of that line would be there. And if we go straight up from there, we get the middle of the line. There we go. Wasn't that easy? We could do the same with the vertical distance, right? It goes from minus 1, okay, the point down here, minus 1, up to 15. So from minus 1 to 15, that would be 16 squares. Half of that would be 8 squares. So if we count up 8 squares from minus 1, 1, 2, 3, 4, 5, 6, 7, 8, the middle of the vertical distance would be there, which is correct. We go across. Okay, which of course will give us the point 9, 7. And that is the midpoint of that line, the middle. You can see it's the middle. Alright, 9, 7. Now, of course, you don't have a grid and a drawing to help you. How are you going to do this? You do it by using the formula. Now, as the answer is in the form of a coordinate, the formula is in the form of a coordinate. Simply what we need to do is we need to add the two x values together and half it. Then we get halfway the x coordinate. Add the two y values together and half that. So here, our first x value is 5, our second x value is 13, our first y value is minus 1, and our second y value is 15. So let's add together the two x values. 5 plus 13, of course, is 18. 18 divided by 2 is 9. The y values, we got negative 1 plus 15, minus 1 plus 15, or 15 minus 1, same thing, is 14. 14 divided by 2 is 7. Quick and easy way to do that. There we go, 9 and 7. 1 mark for each, so you don't even need the working out here. Next is to find the gradient. Let's have a look here. So the gradient, remember, gradient being the change in y over the change in x, or how much you go sideways over how much you go. No, it's the other way around. It's the other way around. The y-axis, of course, is vertical. How much you go up or down over how much you go horizontally. Alright, so looking at here, the distance at the bottom here, remember, what was that? From 5 to 13, that was 8. And then from minus 1 to 15, that is 16 squares high. So we're going up 16 squares. We're going horizontally 8. 16 divided 8, we got a gradient of 2. Positive, of course, because we're going up. Nice if you got a drawing to help you, but what if you don't? Well, you need to know the formula. Gradient being the change in y over the change in x means we need to get the difference between the two y coordinates and divide it by the difference of the two x coordinates. Okay, here being y2, remember, was 15, from which we need to subtract negative 1. Be careful with the signs there. Minus, two minuses makes a plus, so that will give us 16. Sound familiar? Then we take the x values, which is 13, and we subtract from that 5, gives us 8. 16 divided by 8 gives us 2. Same we saw on the sketch. How do we know which order to put these things in? That's a question I often get. Well, you can swap them around. As long as if you swap the x's around, you have to swap the y's around. For example, right? If we were to make minus 1, the y2, and we subtract from that the 15, we'll get a negative 16. That means we just swap the x's around as well, which means we do 5 minus 13. 5 minus 13. 5 minus 13 is negative 8. 16 divided by 8 is 2. 2 negatives makes it positive, get the same answer. So you can write them any way around, as long as you swap both the x and the y. I hope that makes sense. So there we go, gradient is 2, and using the formula or equivalent gives us that answer. Question C. Find the equation of the perpendicular bisector of CD. Perpendicular bisector. 2 words, we need to know what that means. Let me show you. Right, first of all, let's start with perpendicular. Perpendicular, of course, will be a line that crosses the CD line, the purple one, at a perpendicular angle, 90 degrees, needs to cut it. Bisector, bi meaning two, like a bicycle, sector, parts. So we need to cut it into 2 parts, meaning equal parts, cut it in half. Meaning it would be a line that goes through the middle, cutting the purple line in half. You see that? There we go. This line I have now here is at a 90-degree angle, which means it's perpendicular. It goes through the midpoint because it cuts this line, bisects it into 2 perfect halves. And that is the line they want to find the equation of. Remember, equation y equals mx plus c is the equation of a straight line. Alright. Now, this is not hard to get. First of all, remember the c is the y-intercept, where it crosses the y-axis here. What is that? That looks about like 11.5, doesn't it? more or less. Then the gradient, remember the change in y over the change in x. So if we draw a little triangle here, we're going up 1, so we'll have a 1 at the top, and we're going to the left, we're going like this, to the left and up, right, -2, because this is now a negative gradient. The previous one was positive, this is now negative, and that's the equation of the line. Right, easy if you got a little grid to help you, not so easy if you're on the exam and you don't. Okay, or is it? I think it is quite easy if you know what to do. Right, so let's lose the information we have. First of all, we have the gradient of CD. That line is perpendicular to, it's 2. Or we can say 2 over 1. Because for every 1 square you go to the side, you got 2 squares up. Okay, so the perpendicular gradient of the other line going at a 90-degree angle, can you see it's just the opposite? Okay, where first here we went 1 square to the right, well, let's do it, 1 square to the right, 2 squares up. Now it's the other right way around. You go 1 square up, 2 squares horizontally. So what you need to do is you need to swap, invert this gradient, and of course if the one was positive, the other one would be negative. If CD was negative, then the perpendicular bisector would be positive. So this is negative. Cheetah. Right, that helps us a lot because now we can already write the first part of the equation because we have the gradient. So perpendicular line, the gradient, we invert, change the sign. Okay, now we need to find the y-intercept. Let's write down what we have. We got y equals -1/2 x plus c. And c is the thing we need to find. Okay, so what can we do? Is there an x and a y somewhere we can put in there? And the answer is yes. We found an x and a y over here. The midpoint. When you got a bisector, it goes through the midpoint because it cuts it in half, and we have that point 9 and 7. And having that point means it gives us an x and a y. On the line, we're trying to find the quadratic of. So we can substitute that in. We can make the y a 7, and we can make the x a 9. Half of 9 is, of course, 4.5, so -1/2 times 9 is -4.5. Then we move it to the other side, which means the minus becomes a plus. 7 plus 4.5 is 11.5, and that's what we put at the end. Bam, we've done it. Looking at the mark scheme, brilliant, -1/2. They got 23 over 2. It's a bit weird, but you know, 23 over 2 is 11.5. That OE means or equivalent, so my 11.5 would be correct. Well done, done it. Question 16, and these questions is starting to crop up more as well. Changing a recurring decimal to a fraction, and there is a specific way to do this. All right. And follow these steps to get full marks. So the first step here would be to set the decimal value equal to x. Like so. Right, now what we want to do is we want to get rid of the recurring decimals, which goes on for an infinite amount of time. Infinity drives us crazy. We want to get rid of it. Okay, and one way to do that is by multiplying both sides by 100 at least, or 1,000. Why are we doing this? Well, it will become clear as I go along. But I'm multiplying 100 for now because we got two numbers recurring. Okay. Two numbers recurring means I put 2 zeros there. Right, which will give us x times 100 is 100x. and 0.261 recurring. Move that decimal 2 points, that will give us 6.21 recurring, which I'm going to write 2, 2, 1. You know what 2, 1 recurring is. It just goes on forever. 2s and 1s. Okay. Next thing I'm going to do, I'm just going to write that first equation I wrote again over here underneath, ensuring to line up the decimal point perfectly. Now, see, I made a mistake there. That decimal point's in the wrong place. Let's just do this again. Okay. If you multiply it by 100, it becomes 62.1212212. B sharp. So when I write the next one, it will be 0.6212. You see what's happened now? I have lined up those 2s and 1s that goes on often to infinity perfectly well. 2, 2, 1, 1, 2, 2, 1, 1. Which means what I can do now, I can subtract the one equation from the other one. Because 2 minus 2 is 0, 1 minus 1 is 0, 2 minus 2 is 0, off to infinity. Which means all the infinite numbers of 2s and 1s disappears. Which is beautiful. Up to here, everything would disappear as I subtracted. And there's no more infinite now number of decimals. We just need to do the rest. We need to do 1 minus 6. So we borrow a 1 from there, put it there. 11 minus 6 is 5. 1 minus 0 is 1. Now we got a terminating decimal. That was our whole mission from the start. Let's do the same on the left. 100x minus 1 will give us 99x. So that means x is 61.5. Divide the 99. Excellent. We got a fraction. Do we? Well, it says we need to write it as a fraction in its simplest form. Okay. Now, if you write a fraction in its simplest form, we cannot have a decimal mixed with a fraction, because if you do that, there's an infinite amount of fractions you can write when you mix it with decimals. I mean, we can write 61.5, we can write 0.615. It will never end. So what we need to do is we need to make these integers, whole numbers. Luckily, we know about equivalent fractions. If we do something to the numerator, we need to do the same to the denominator. We'll have an equivalent fraction. So just multiplying the top by 10 will make it 615. No more decimals, as long as we do the same to the bottom. And there we got a fraction, 650 over 990. We can check if it's correct. Okay, CC is already there. Let's do it again. 615 over 990. Bam. No? There. 0.621 recurring. Exactly what we wanted. Excellent. Okay. Is it in its simplest form? No, but our calculator, most conveniently, does give it to us in the simplest form. 41 over 66. And that will be the final answer. And we've done it. Okay. Looking at the mark scheme, they multiplied it by 1,000, which you can also do. Then you'll end up, don't have to do that step I did there. Okay. As long as you line up the 2s and the 1s, so that they, when you subtract it, they disappear. You have to line up the recurring decimals. Then it will work. Okay. And this is the best way to do it. Okay, full marks there. Interesting here, it says less than half of everybody got this right. So you can learn how to do this. You'll definitely be, well, you're going to, you can do it. You learn how to do it, get your marks. As I say, it's been cropping up more lately in the exams. Question 17, you see a triangle, you know trigonometry. So before we start jumping into Pythagoras, Socatua, cosine rule, sine rule, let's see what is going on. They mention the area of a triangle. Now remember, there's two formulas for the area of a triangle. There is half base times perpendicular height. Okay. If If you don't have the perpendicular height, you can do half AB sin C. Alright, those are the two formulas for the area of a triangle. We don't seem to have any perpendicular height here because we don't have any 90-degree angles. That's given to us. So I will assume we use that second formula. So let's write it down. The area of a triangle is half AB sin C. So what do we have in the formula? Well, we got the area. It's 2, 1, 4, 3. What is that? It's not a 2. No, it's a 2. Half. Now what's AB and C? Well, since C would be the angle. So we're going to make this C, because that's what we want to know. That's the angle, which means the opposite side there will be the lowercase c, which we don't need in this case. What we need is the two sides enclosing the angle. Which one is A and which one is B? Well, this really doesn't matter. You can do them any way you want. Okay? Any way around you want. You can make 71A and 92.5B. Doesn't matter. As long as you just put them two. So let's do 71. No, wait, I made it 92.5. Okay. 92.5 and 71. Sin and C is the angle we want. Let's make it X. Right. So, how are we going to find X? Well, all of this is being multiplied with sin. So if I move it to the other side, we need to divide it. We can work it out actually beforehand. Let's do that. Let's work it out. Let's see what it gives us. Hopefully it isn't some crazy decimal. Okay, a half, 92.5 times 71. Yeah, not crazy about it. 3283.75, just unround it. Did I get it right? No, see how easy it is to make mistakes. Fine. Now I'll move it to the other side. So we need to divide I can't move it yet. See that's not correct. 2, 1, 4, 3. And the next step we'll divide it. And that will be equal to sin x. So we need to move that sin to find out what is x. Sin to the other side means we need to do the inverse of sin. Sin minus 1. Okay. 2, 1, 4, 3. My goodness. Don't make any mistakes. Yeah, I still got that there. So I'm going to press shift, sin, fraction, 2, 1, 4, 3. Insert the previous answer. Now I know I didn't make any typing mistakes. And we got the answer. 40.738. If you're going to round it, it says at the beginning of the paper, all angles can be rounded to one decimal place. That's a 3, so that stays a 7. So it's 40.7 degrees. Correct, 40.7. Unrounded answer also gives you full marks. And you get a mark for writing the equation down. So you're working out. Be careful of premature rounding. Again, so that's one. I had all those decimals numbers. Don't round it until the end. Because if you get out of range, you lose accuracy, you lose marks. Question 18. Make x the subject. They love to put this in the papers as well. And there's two x's. Alright, first thing to do is get rid of any fractions, any denominators, right? So we're going to take all of this multiply it on the other side, because the opposite of divide, multiply. So this will be c times all of that. Keep things organized, yeah? Equal in the middle, two sides, left and right. You won't get confused. So you know what's on the left, you know what's on the right. If you know, you move it, change the sign. So next thing we do, we expand the bracket. C times 2x is 2cx or 2xc. C times minus 5 is minus 5c equals 3x. Nice. What we can do now is we can move all the terms with an x to one side and everything that doesn't have an x to the other side. Meaning, I've got the 2cx here, and I'm going to bring the term with an x to that side. This is a positive 3, right? So it becomes negative 3x. This minus 5c does not have an x, so I'm going to chuck that to the other side. The minus becomes a plus, so it's 5c. This is now when the magic happens, where we have got two c's. We've got to make it into one by factorizing it out. So we take that x, we put it in front of a bracket, and inside the bracket we put what is left. Check that it's right. X times 2c is 2cx. X times minus 3 is minus 3x. That is correct. And we're almost done. This is x times that whole bracket. So we move that to the other side. Times becomes divide. And that, ladies and gentlemen, is the final answer. Easy as that. 5c minus 2 minus 3 or equivalent, final answer. I think what could be equivalent to that is if we did this step differently. If we left the minus 5c there, we had the 3x and we moved the 2cx to the right. Okay, which means when we factorize out the x, we'll get 3 minus 2c, and then we divide, which gives us 3 minus 2c equals x. That would be an equivalent answer. Okay, which is everything's the signs are different. The 5c is a minus 5c, the minus 3 is a positive 3, the 2c is a negative. I believe that is equivalent, which they didn't put in the mark scheme. Question 19. Proportion. Right, the first step doing these proportion questions is to put this first sentence into a mathematical language using the fish. Right, meaning m is proportional, that's the fish, but inversely, which means it needs to be inverted, reciprocal, to the square. Be careful, square, not square root. This is a common mistake. People put a square root when they should be speaking a square of t plus 2. So we do t plus 2 square. Now that whole sentence, math language. We need to change this now to an equation, changing the fish for an equal, where we need to bring in a constant k. This is proportion. Remember, like something is proportionally bigger, 2 times as big. This is that ratio. How much bigger it is, or smaller. It's half, it's a third, it's 5 times bigger. That is the k that we need to multiply it by. Okay. Now we got the equation. We can work out the constant of proportionality, it's called, by substituting these values into the equation. So m is 0.64 and t is 3. Okay. 3 plus 2, of course, is 5. 5 squared is 25, so that means k. Multiply that over there. Will give us the constant of proportionality. 0.64 times 25. Bam, 16. Beautiful integer we have. Good, that was good progress. Now we can rewrite our equation. This one here. Okay, that's the equation. We write m equals, but we know now k is 16, so it's 16 over the square of t plus 2. Why is this good? Because now we can use this equation to work out any other value of m or t if we got 1. So we got t is 8, so we can work out what m is by putting an 8 where the t is, which of course gives us 16. 8 plus 2 is 10. 10 squared is 100. 16 divided by 100 is 0.16. This is one of those type of questions where you learn the steps, you can't go wrong. There's not many of those, but this is one of them. 0.16 or equivalent. I guess 16 over 100. 8 over 50 is all correct. Okay. 1 mark for writing the equation with the k. Substituting the values in there gives you another mark. Show you're working out. Okay, be careful not to put a square root instead of a square. Be careful for direct proportion not to mess that up. Question 20. Venn diagrams. Remember the basics. We've got intersection, which kind of like an and. Something has to be required both. It has to be this and that. Okay, it needs to require both requirements. Where we got union, it's more like or. It's in the one or the other, or in both. Okay? Intersection must be the one and the other one. Union, right. Intersection is strict, union is relaxed. Okay, so let's have a look. Let's start. Right. So let's mark this with our pencil. So region A. A has all these regions. That one, that one, that one, that one. That is all A. Okay. Let's use blue for B. Now the complement of B, the little b, means everything that is not B. So it means outside B, but also here, this is not in B. This is not in B. This is not in B. Everything else is in B. Alright? Last one. C. Let's do this one in orange. So C being, this is in C, this is in C, this is in C, this is in C. Okay. Now this being intersection means it has to be in the one and the other and the other. Has to fulfill the first requirement and the second and the second. There's no union. So it's only where I now have all 3 dots. That is what we're going to shade. Do it in red. Make it smaller. Okay. Meaning this is it. And that's the answer, ladies and gentlemen. You can rub out any working out we did on pencil. And there it is. Okay. Something that requires a bit of practice. You can do it. About half of everybody got this question correct. Question 21. We are solving the equation for 5 sin x equals minus 3. So let's start off by doing normal solving an equation. Right. First thing would be, this is 5 times sin x minus 3. So we divide both sides by 5, or we divide the 5 on the other side. That gives us minus 3 over 5. Next, the sin, which means we need to do the inverse of sin. Okay, so let's do that on the calculator. By the way, that minus, you can put it above the line, below the line, in front, doesn't matter. And we get an answer, minus 36.869. Nice, easy. But there's a problem. It tells us the answer needs to be between 0 and 360. Okay, and ours is less than 0. So this is not the final answer. Definitely I'll get a mark. At least, probably only 1 mark. We need to find the other values. This is when we need to remember what does a sun graph look like between 0 degrees and 360. Okay. Remember there's 180, there's 90, there's 270. Do you remember what it looks like? Well, if you forget, just put it in your calculator. Sin 0, well, that's 0. Sin 90, that's 1. So, sin graph starts at 0. When it gets to 90, it needs to be up at 1. You know, and you put sin 180. That's 0 again, so it goes down to 0. And if you put sin 270 out, then it goes to -1. Yeah, remember this? Okay, of course it continues this side as well. And that is where we got one of our answers. Okay, if we continue the graph here, -3/5, of course, is -0.6. So that means if we're at -0.6 here, then the answer is -36.9, roughly. Okay, but we need to look for the positive answer. So if we continue across here, I'll say, oh, there we're going to get the positive answers. There's going to be 2 of them. One going down from there, one going down from there. You see that? Okay. The bit of a thing about sun graph, it's all symmetrical. So if this distance here, this distance here is 36.9, roughly. Then this distance here, which I haven't drawn really nice, is 36.9. Meaning we can find another answer by subtracting 36.869, 360. Let's check if we're right. 360 minus 36.869, 323.131. Okay, it's a bit rounded. Is it correct? Well, if we put that into this equation there, we should get -3 or very close to it, because we now not that accurate anymore. So if we put 5 sin 323.131, close the brackets. Yes, look at that, -2.9999 -3. So I know this is definitely one of the answers. Do they say how we need to round it? No, but it's an angle, so round it to at least 1 decimal place. It says that on the front of the paper. Okay, but remember there was another answer there. Okay, and again, it's all symmetrical. So this distance here would also be 36.9. So all we need to do is do 180 plus 36.869. What would that be? 216.869. Let's check. Let's check if it's right. If we do 5 sin 216.869. Yes. Okay, round it, -3. So there's another answer. X rounded to 1 decimal place. 216.9 degrees. They make this harder. Usually on the paper they put x equals x equals. You know you need to get 2 answers, but Now you just need to know it. Okay, question 21. 216.9 or a more unrounded answer, 323.1. Okay, so mine is correct. Yes, 1 mark for just dividing the 5 on the other side. Okay, right, I see there it helped to sketch the curve, so people can write that. There's also a cast diagram, which we can do another day. Question 22. This paper has become a lot of fun. They want us to add 2 algebraic fractions. So remember the basics of adding algebraic fractions. If you're going to add, let's say, 2 fractions together, one method there is, call it the smiley or face method. You multiply the 2 denominators together to get the common denominator. And then you multiply across 4 times 1, because 4 over 12 is the same as a third, equivalent fractions. Okay, I don't know why I put a times there, it was a plus, of course. And you multiply the 3 across, because 9 12 is the same as 3/4, and then you can add it together, and you have the answer. Okay, we are going to do the same thing here, just with the algebra terms. So first thing, we multiply these 2 together. Now we don't have to actually do it. We can just write them next to each other. Okay, we don't need to expand the brackets. We need to multiply those 2 together. Next would be to multiply the 2x minus 1 with a 5. So you get 5, 2x minus 1. There's a plus, there's a 4. And we multiply the 3x plus 2. Bam. Now we simplify things. Okay. Expand the brackets. 5 times 2x is 10x. 5 times minus 1 is minus 5. 4 times 3x is 12x. 4 times 2 is 8. Careful with the signs. This time they made it easy. There were no negatives there in that second term. But if there is, people used to get the terms wrong. Okay, below the line, stuff is still the same. Simplify. We got the 10x and the 12x. We can add them together. So that's 22x. The minus 5 plus 8. That minus is with a 5. So it's like 8 minus 5 is a positive 3. And I believe that's the answer. I mean, we've done enough for 3 marks, haven't we? If there was 5 marks, I would maybe look if anything can be cancelled out. But I believe we've done it. There we go. You see that? Don't need to expand the brackets at the bottom. Okay, and not that difficult, yeah? You get 1 mark for writing that together, 1 mark for showing the top part. Just already, and then all of your working out. I think if you do expand the brackets below the line without making a mistake, they won't mind, but give you full marks. Yeah, so be careful. It says a lot of students did expand the brackets below the line, but some of them spoiled their answer. So if they just left it without expanding the brackets, they would have gotten more marks, because when they expanded it, they made a mistake, and that cost them marks. So be careful if you expand the brackets below the line, that you don't mess it up, all your good work. Question 23. Before we start, just note, yeah, this being the last question on the paper, they probably try to make it the hardest. More than half of everybody scored nothing. Okay, so it is a challenge, but we're ready for it. You can do it. And I would prefer to do a tree diagram for this one. Okay, so we need to think, there's bag A and bag B. And bag A goes with Anna, and bag B goes with Ben. So, yeah. So, in these bags are red and yellow sweets. So when Anna takes a sweet out, we're going to do this in the right color. She can now pick a red or a yellow sweet. Okay, just go slow. The probability that she picks a red one is 2/5. So that means if there are 5 sweets in the bag, 2 of them are red. But we don't know if there's 5. There could be 10. If there's 10 sweets, 4 of them are red. Either way, the probability of getting yellow one is 3 out of 5. Okay, then comes Ben. And let's see what it shows, all the possible things that could happen. Okay, bag B, Ben takes a sweet out of bag B. And again, bag B contains red and yellow sweets, of which we don't really know much of how many there is. Okay, all we know is the probability that Anna and Ben both pick a yellow sweet is 1/10. Meaning, they told us that if we go down this route, where they both pick a yellow one, the probability would be 1/10. That's all we know. How would you go around finding that 1/10? That is the question. Well, when we move along a tree diagram, we need to multiply the probabilities together. So I'm going to call it X. The probability of finding a yellow sweet in bag B will be X. Meaning, to get 1/10, we need to do 3 over 5 times X. Gives us 1/10. Okay. Because the one thing and the other thing needs to happen. So if we want to know what X is, we need to do 1/10 divided by 3/5. Let's do that. 1/10, of course, is 0.1 divided by 3/5, which of course is 0.6. There we go. X is 1/6. That helps us a lot. So now we know the probability of Ben picking a yellow sweet is 1/6. So if there's 6 sweets in the bag, 1 will be yellow. If there's 12, 2 will be yellow. Alright. Meaning picking a red one, the probability will be 5/6. And the probability stays the same all the way through. Now, what is the question? The question says, find the probability that Anna both pick a red sweet. So it means Anna needs to pick a red one, Ben needs to pick a red one. So, moving across, 2/5 times 5/6. 2 times 5 being 10, 5 times 6 being 30. Simplify that to 1/3. 1/3 is the probability. They both pick a red one. Thank goodness. It's correct. Or equivalent. 10/30ths, 0.3 recurring, 33%. Those are all correct answers. Doing a tree diagram helps. We've done it. This was fun again. Glad to see you. See you again soon with paper 42. Tot ziens.